Hello, in this video we're going to be looking at the Universal Windows Platform composition APIs, and in particular we're going to be taking a look at visuals. I'm Darren May, President and co-founder of Crank211. I'm also a Microsoft MVP for Windows development. At Crank211 we design and deliver universal Windows applications, web applications, cross-platform mobile, and we also create and deliver training courses. You can find me on Twitter at Darren May and on the web at www.crank211.com. So let's talk about what composition is. If we first think about Windows UI XAML, then this is our framework layer, and what this provides us is the ability to easily create UIs. We have very rich controls that have a whole bunch of capability in there, know how to render themselves. We have layout controls such as grid, relative panel, and so on and so forth that helps us construct and lay out the UI. We have a whole bunch of additional features such as accessibility, rich data binding, one-way, two-way, and so on, that really allow us to build our applications, but that comes at a certain price. If we then think about DirectX, this allows us to access the metal, our high-speed graphics card capability. But these are low-level primitives, and so in order to construct a UI using purely DirectX, you've got a lot of complicated concepts to get your head around. You have to build these things up using primitives. It provides us the text rasterization, the ability to render ink very quickly. That's how that performance gets to be. But it's not the easiest thing to use. Kind of think of it a bit of a barren, rocky wasteland in terms of how easy it is to use. So where composition sits is, I like to think of it as the plush velvety cushion that sits between the raw power of DirectX and the ease of consumption of the Windows UI XAML framework. Windows UI composition is a rich set of APIs that really let us access the capabilities of Windows 10. It provides us access to visuals, which we'll talk a little bit more in a moment, animations and expressions, which we'll cover in another video. Effects, again, we'll cover those in another video, and so on. So that's really where this sits. It really unlocks the ability to create extraordinary experiences in your Windows 10 application. Of course, this is just a high level. If you want to dive more into the details of what's going on here, then obviously the Microsoft documentation is a great place to go. They're doing a lot of work right now in really ramping up the breadth and depth of this documentation, so I suggest you visit this. One of the things that you will be using an awful lot when you're working with composition is you're going to be using the compositor, and this is effectively an object factory. It allows us to reach into the composition system and create objects that represent visuals, that represent the effects that we would perform, to create animations and execute those animations. It also manages the object lifecycle of these things because it's low level. These aren't necessarily managed objects. These are objects that are wrapping around COM, for example, and so we need to make sure we're managing those life cycles, and the compositor does a lot of that work for us. We can obtain the compositor in a number of different ways. We can either get it from our current window, which is a new feature that recently shipped in the SDK, or we can get it from back in visuals, and we'll be covering that in a moment in a demo. So what can we do with the Windows composition? Well, I kind of mentioned visuals, and we'll go into those in a bit more detail, but these are effectively surfaces on which we can render and manipulate, and these things work very closely with the graphics card capability so that we can do things in a very smooth, performant way. We can also use a lot of effects that has previously been missing from UWP XAML. We can do Gaussian blurs, we can do blends, and so on and so forth. We're actually leveraging a lot of capability that's been exposed up by Win2D, which is another project from Microsoft that's actually, you can read up on this blog entry that is here, blogs.msdn.microsoft.com, Win2D. They also have a GitHub repository where all of the code is actually placed out, and I'll have a link to that repo at the end. We can also use a new animation system in composition, keyframes and expressions. You might say, hey, what's wrong with the animations and storyboards that are in UWP XAML? Well, there's nothing really wrong with them, except that some of them aren't quite as performant as perhaps they could be, although a number of them have actually been changed to use composition under the covers right now. Another key thing about composition is it works well with XAML, in that you can grab the rendered output of a XAML control, get its backing visual, which is effectively what's being handled low level inside the system, and then manipulate that. One interesting thing about composition actually is you don't actually have to use XAML at all. You can actually build an entire app UI, entire application just using composition, which is almost the same as building it just using pure DirectX. It's very interesting, but not something I'm going to cover. Another interesting feature that's just been released as part of this is custom brushes. These are composition islands that you can use that will actually drop in anywhere in XAML where you would use a custom brush, and we'll demonstrate that in another video as well. So I've been talking about visuals. So what are they? Well, ultimately, a visual is a node in the visual tree. If you're familiar with XAML, then we have the concept of a logical tree, where we lay out our controls, and it kind of has a almost one-to-one relationship, if you like, with the XAML that we create. Then we have a visual tree, which is how those elements are expanded out into the underlying controls and surfaces and so on and so forth that are actually being rendered. Well, the visual, or the backing visual, I should say, for one of those elements, is the outcome of all of that rendering and how it's been handled in the compositor inside Windows. Beyond that, we have a number of different types of visuals that inherit from this core visual. A container visual is basically the same as a visual, except it can also contain children. So that allows us to stack up multiple visuals in a similar layer and so on. We then have a sprite visual, which inherits from container visuals, so it can have children. But the key thing about this is we can then start rendering our own content onto this visual using a composition brush. So we can load in images, we can create solid color brushes, and we can really render up a very custom UI into a sprite visual, which we could then load into an existing visual in the visual tree. Let's stop talking about that and let's dive in and start showing how we can actually deal with some of this. So let's get started with showing how we can use visuals and composition in a simple app. I'm going to create a blank Windows Universal project, and let's just call it App 7. Here's where we would select our targets, and as you can see, I actually have the Windows 10 Creators Update SDK version 15052. This unlocks all of the latest composition features and so on. Okay, so now we have our simple UWP application. What I'm going to do is open up mainpage.xaml. And here I'm going to create a very simple UI. So we have a grid already, we're going to use that as the basis. And I'm going to put in two elements here. I'm going to put in a rectangle, which will be used so I can demonstrate how my other visuals move related to this. I'm going to call this xName equals background. And we're going to have some alignment properties. We're going to say vertical alignment top and horizontal alignment left, and we'll see why we're doing this in a moment. We're going to have a fill color. Let's just have it a lovely blue, and then let's put some fixed dimensions on here. So we're going to have height of 500, and we're going to have a width of 500. Okay, so there's my background, and now I'm going to create something that I'm going to place in front of it. We're going to have a grid. I'm going to call this a fancy grid, because why not? And we're going to do some similar things with the vertical and horizontal alignment, so we make sure that it's sitting on top of the rectangle we just created. So that's left aligned, and we're going to give it the same dimensions. Height and width. And we're going to give this a background color of yellow so we can tell the difference between the two. Filly, no, just fill. Oh, background, no, that needs to be yellow. What am I doing? Okay, yellow. So now we're going to just set up a basic layout. So we're going to have a couple of row definitions in here. This one will just have star size, which means it'll expand to fill the available space, and then this one will just have its height being auto, which means it will size itself based upon the contents of that row. Okay, let's add a couple of things in here. So we're just going to have a text block, going to have text wrapping to wrap whole words, and then we're just going to put some garbage in here. So let's just say yada yada, blah blah. So really useful stuff, and then we'll repeat this a few times just so we get some nice wrapping going on. Well, nice wrapping is a relative term. So we've got that content in here, and then let's come to the end, add a stack panel in here, and its orientation is going to be horizontal, and it's going to be in grid.row equals 1, so it's going to be in the second row of the grid using the 0 index, and then we're just going to put a few buttons in here just to place some interactive controls on here. So if we flick over to the design view, we'll see we have this lovely UI. Okay, and now I'm going to run the application just so we make sure everything's hanging together. Okay, so here we can see we have our wonderful UI. Oh, let's put some margins around those. So let's just quickly show we actually have some very nice features in Windows 2007, Visual Studio 2017, which is we can do live editing of our XAML. Just drop these in here. Save that, and if we come over to here, we can see it's automatically been reflected. So that's very useful if you're debugging and so on, and if you forget to say put a margin in and you want to see how it looks. Okay, so we have our application here. So nothing particularly stunning here, but now what we're going to do is we're going to talk about how we can access the backing visual for our fancy panel here and how we can actually perform some interesting effects. Let me just change. So now we'll zoom it in so we can see how it will appear on our screen. Okay, let's go to our code behind. So here we are in our Visual Studio environment, and so what I'm going to do is I'm going to subscribe to loaded, create a method for onloaded, and we'll have nothing in there for the time being. I'm also going to create an override to onNavigated to. Okay. So what I'm going to do here is I'm going to apply some composition capabilities. So I'm just going to create a method and we're going to create that method. Okay, nothing fancy. So first and foremost, you recall previously we talked about the compositor. The compositor is the object factory that allows us to interact with APIs as part of the composition layer. So we need to get hold of that compositor. Previously, we would do that by getting hold of a backing visual for an element and then accessing the compositor on that. But instead, what we're going to do is a new feature in the latest version of the SDK, where we can say window.current.compositor. So it's a nice global way for us to access the compositor for any window that we're in. Makes it very useful when using brushes and so on later on. Anyway, we've got a compositor, and we'll be using that when we're creating visuals. But first and foremost, we actually want to get the backing visual for our fancy panel. So backing visual, we're going to grab that by getting our element composition preview, which is part of the XAML hosting namespace. And we're going to say get element visual, and then we're going to pass in our fancy grid element, and that's going to return back the visual for that. So that's awesome. We've now got the visual. We now have a gateway into performing interactions with that visual on the system. So one of the first things we typically would do is perhaps move that visual. So what we're going to do is we're going to create an offset. And offsets take vectors. So it's going to be a new vector 3. So vector3 has 3 values, and we're going to move it, say, let's move it 100 by 100, and we're not going to move it in the z direction. So we're just going to move its x and y. So that's going to actually offset this. So let's run this. So now what we can see is we've captured the visual of our fancy panel, and it's moved right at 100 and down 100. And we can see it's moved based upon the fact that we've now revealed the rectangle that was sitting behind it. So as you can see, this is a relative position of the visual based upon where the parent element, the owning element, is. So this seems to make sense. But let's get rid of the horizontal and vertical alignment properties and see what happens there. Now, because we're working with composition, we're going to need to restart our app. We can't change this live and expect it to update. So what I'm going to do is I'm going to remove our vertical alignment and left horizontal alignments on both these elements. And so what a grid will do is it will position it in the center of its available real estate. So now let's run that. So we now have everything appearing in the middle. But wait a minute, don't we still have our offset? It's still right there. What's happened to our offset? Well, because the visual is owned by the element, whenever certain properties get updated on the owning element, they also stomp on any changes you've made to things such as the offset in the backing visual. So that creates us a problem, because what's actually happened here is, by virtue of saying to the grid, position the content where you want it to be, a layout pass runs. And when that layout pass runs, it establishes where it wants to position these things. And so unfortunately, the net effect of that is it stomps on the fact that we want to do an offset. So that seems like a bad thing, and it's often not what you would expect to see. So let's see how we would go about actually correcting that. So if we come back into the code here, what we would typically do here is we'd enable a new feature. If we come into element composition preview, there's a method on here where we can turn around and say set is translation enabled. And what we're actually then going to do is say, well, our fancy grid, we're going to enable translation. Now, translation is going to interact with a set of custom properties that we're going to attach to the visual that will work outside of the property stomping of offset. So if I take a look at this, what we're actually going to do now then is we're going to turn around and say, let's get hold of the property set for our fancy grid. And we will cover property sets a little bit more detail as part of effects and animations. But in order to do this, we're going to get the element composition preview, which is our gateway into our visuals. And we're going to get the element visual once again for our fancy grid. And we're just going to say properties. Now you might notice, of course, we already have the back visual for our element, so we could actually do just this. We'll do the same effect. So now fancy grid property set has been set with a bunch of properties associated with the backing visual. What we're going to do now is we're going to insert a new property into this set. So fancy property set dot insert, and this is going to be a vector 3, I believe. Yes, it is vector 3. And so we're going to first of all specify a property name. So this is a magic string that says it's translation. We've enabled translation above, so this is the property that we're going to be updating, and we're going to set its value to a new vector 3, and we're going to do the same thing. We're going to set its offset to the same values that we want above, and again no zero index on there. So we actually don't need this offset anymore. So we're going to save that. Now we've applied that, let's run that and see what we get. So now what we can see is by applying that translation, it's now a translation from where the layout has positioned the parent versus creating an offset that gets stomped by the layout. So that's how we deal with property stomping with regards to translations and so on. Anyway, let's jump back in. So some of the other things we've talked about is we have some other properties here. So let's get hold of our backing visual and let's change its opacity as an example. So it's a property on here, let's set it to 0.5, which means it's got 50% opacity. So if I run this, we can see that the opacity works. So again, this is working in the composition layer. This isn't the same thing as setting the opacity on our grid pattern. So we can do some other things, such as we can rotate it. So let's come set its rotation, back visual. So we actually have two ways we can set rotation angle, one in radians and one in degrees. I think in degrees, so let's do 45 degrees. So let's run that and we can see how that impacts our UI. So we can see that we have our UI and it's rotated. Incidentally, if you actually have a look here, we can see that we still have full interaction with these buttons and controls. So they actually all still work. We're just taking the output of the render and manipulating it in the composition layer, but it understands exactly where these things are. And we can see how the focus rectangle got a little bit upset initially by this layout. So we can see how all this works. But what you might have noticed is the rotation is based upon this top left corner of our visual as opposed to the center of the visual. That may be the effect you desire, but it's actually not the effect that I want. I want to rotate it based around the center of here. So let's go into our code and change that. So our backing visual, if I could type, has a center point. And so we need to set that to be a vector again. Now, so this center point needs to be based upon the dimensions of our actual fancy grid. So if we do fancy grid dot actual width divided by 2.0 float. Now we're still getting a red squiggly here. That's because this needs to be cast to be a float. So we do that. Copy this. So now we're going to set the vertical offset. So we need height. And again, we're going to give the z-index, good ignoring. Okay, so we've now set our center point to halfway through everything. Let me run this again. And lo and behold, it didn't apply. Now, why is this? Well, if we look at and see where we've actually implemented this, we've applied our compositions on the on-navigated 2. The unfortunate outcome of that is that we actually don't know the actual width of Fancy Grid at this moment in time. We generally would know it on loaded, and we'd also know once if we monitored, say, updates to our Fancy Grid. But let's take apply composition out of on navigated 2 and drop it into on loaded. And now let's run it. So now we can see that this has been rotated based upon the center of this position. If we pulled this back to where it was for 45 degrees, you could see how on the arc of transfer it would be here. So we can see how this has now been applied appropriately as we would expect. Okay, so that's showing how we can manipulate some of the properties of the actual backing visual for our Fancy Grid. But we also talked about how we can create sprite visuals and container visuals that would interact with this. So let's first of all create a sprite visual. This is where we're actually going to leverage our compositor. So let's create sprite 1. And it's going to be an object that's created by our compositor. So we're going to create a sprite visual. And let's set some properties on there. So unlike the backing sprite where we cannot set the dimensions of it, with a sprite visual where we actually control it completely, we can specify its dimensions. So if we specify its size, let's say its size is going to be a new vector 2, 50, 50. Okay, and let's, just so we make sure we don't stomp on things, let's say it's offset, and let's say that is a new, and we know that's a vector 3. And so we'll do it, where should we move it? 50, 50, 0. Oh, I said 40, 50. Okay, so we have that. So now we've created that, but we've got no content in our sprite visual. This is where we're going to start using brushes. And you mentioned there are a number of different composition brushes. We're going to use a very simple one right now, which is going to be a color brush. So let's set the brush. So sprite1.brush is equal to compositor, because remember this is our object factory. So we're going to create a color brush, and we're going to set that simply to, we're going to bring in our colors reference. So we're going to set that one to, let's do green. Why not? Okay, so now we have a sprite that's 50 by 50. It's offset from whatever parent it happens to have by 50 and 50. And it's going to be filled with a solid color green. But we haven't actually set its parent yet. So the way that we do that is we can turn around and say, okay, ECP, this is our interaction with elements. So we're going to set element child visual of our fancy grid to the sprite we just created. So now that we've done that, this should now be included as part of the UI composition, and we should see our green rectangle. So there we see it. It's actually been positioned as you can see, it's taken into account the rotation that we've applied to our backing visual. So it's positioned 50 by 50, and you can see its dimensions 50, 50, and it's got the green brush. So all of this is working as we would expect. So previously, we also talked about the fact that you could have a container visual that can contain one or more children. So let's look at how we would actually create a container visual. So let's create our container. And again, our compositor object is the factory that will create our container visual. So we have the container, and it makes sense that the container would be the child of our fancy grid, because that is going to contain other objects. And so then our container needs to have its children set. So let's look at container. And sure enough, we have a property called children. And then we have the ability to insert items. So let's just turn around and say we're going to insert this one at the top. So insert at top, and we're going to specify sprite1. So now if we run this, we see exactly as what we had before, except sprite1 is now inside a container visual, and the container visual is set as the child element. So let's create ourselves another sprite. So I'm going to copy this code, make this sprite2, and let's make this purple. And let's change the offset of this one to be just 25. So we're going to insert sprite1, which was the green one that we had, on the top. And then we can say insert at bottom sprite2. Okay, so sprite2 should be beneath sprite1. So let's run this code. Now we can see that these elements are underneath, and you can see that the green is sitting on top of the sprite. Let's get rid of some of the opacity and see how this works. Let's delete the opacity from up there. Run it once again. So now we can see all of these things with the full opacity. So you can see that the green is sitting on top of the purple. Okay, so that gives you an idea of how you can interact with sprite visuals and how you can leverage container visuals to contain more than one sprite visual and position them. So obviously we can do a bunch of things associated with these, with different brushes and so on, and I'm going to create a video which talks about some of those brushes later on. But one of the things that I do want to show at this point is that it's very, very common that you would want to load an image into one of your sprite visuals. And so previously that wasn't particularly easy. You would have to dive into Win2D and create a surface that really is a DirectX object. And to use that surface, you would then create a surface brush. You would have to load the image yourself and manage the life cycle of that image yourself and so on. But the composition team have listened and know that that is a complicated scenario. And so instead what they've done is they've attached into the image cache that's used by XAML so that you can actually create surfaces directly from those images. So let me show you quickly how we will do that. So what we're going to do is we're going to create a new set of objects. First thing I'm going to do is I'm going to create a member variable. One of the things about the loaded image surface element or control or object is that we need to manage its life cycle and we need to make sure we dispose of it when we're finished with it. So I'm going to create a private variable for that, and then let's go down and use it down here. So we're going to set this equal to the outcome of a static method where we're going to load from a URI. Now what URI are we going to load from? Well, we need an image. So I'm going to create a new URI. What I'm going to do is drag an image that I prepared earlier into our assets folder. So let's drop that into there. So we've got just enough bikes.jpg. So now we're going to reference that over here. So if you're familiar with the URI syntax, so msappx says that we're actually referring to something that's part of our package, and we've got // which is the protocol, and then / indicating it's from the root of our application package. So we're in asset, and it's just enough bikes.jpg. So if we look at this, we've got a good hint of what's going on here. It says start load from URI. So it's actually not going to run immediately. It's going to be an asynchronous operation. So we're obviously going to need to make sure that we handle something associated with this. So if we look at loaded image service, we actually have a load completed event. So what I'm going to do is subscribe to that event, and I'm actually going to use a lambda. So sender, let's call that sender 1. Ooh. Sender, and let's create our function. And so we need to check args to make sure that our image has been loaded successfully. Now obviously if you're building a production application, you probably want to handle the other states such as network error, invalid format, and so on and so forth, and have some sort of fallback image. But seeing as this is a contrived demo, we're going to assume success. So we're in here, we've got success. Now what are we going to do with that? So now we actually need to create a brush from the image that's been loaded. So let's create a brush. Brush equals, and we're going to use the compositor again. We're inside a lambda within the scope of our apply composition method, so we still have the compositor in scope. We're going to create a surface brush, and we're going to create that from our loaded image service. So here's our loaded image surface. We're going to tell our brush that we want it to stretch uniform to fill whatever dimension that our brush is applied to in terms of a visual. So we need to create a visual that's going to host it. So let's image visual equals, so let's compositor again to create a sprite visual. going to set our image visual size. Let's make it, what should we do, 400 by 400. That would have been nice if I could just write it like that, wouldn't it? Vector 2, 400 by 400. And we're going to set our image visual brush equal to the brush we just created. And let's just add it to our container. Children. So let's put it on top of everything else so it appears. So let's create our image visual. Now, as I mentioned before, we need to worry about the life cycle of our image surface. So let's turn around and deal with that. I'm going to create an override, if I could spell it, on navigate from. And we're going to do a check to see if our loaded image surface is not equal to null. We're going to assume we haven't disposed of it. So then we're going to call dispose. And then we're going to set it to null so we don't have any references hanging around. So let's release that. Okay, so obviously in a single view application, this is relatively unnecessary because these things will be tidied up when we shut down. However, if you're doing this within the context of a navigation application where you've got multiple pages, then this makes a lot of sense. So let's run this up. I misspelled my path. It should be assets. Let's run that again. And here we can see just enough bytes is the image that's been loaded based upon the dimensions, and again it's been arranged and rotated because of its association with the parent. So that's how we can bring images very easily now into composition. So that wraps up what I was going to show in the demo, so let's go back to the slides. Okay, so we've just shown how you can use some of the visuals. Here are some additional resources that highlight some of the things we've talked about. The session source, for example, I'm going to be putting up on GitHub, Crank to 11 composition. Here are a bunch of links for Microsoft resources, so I suggest you pause this video and go out and visit some of these resources. Okay, if you stop pausing it, that's the end of this video. Be looking for more of these videos where I'll be going into details around animations, effects, and so on and so forth, and how we can bring a lot of these things together and create some advanced experiences in an application.